In this video, we'll look at question 77 from the 2016 paper. So here we have a convergent geometric series, and we know that the first term equals 8, fifth term 2, and the sixth term is positive. And we are supposed to find the sum of this geometric series. This will be fine because we know that it's convergent, so it won't be infinity. It's all good. And in order to do that, we'll need to find the common ratio and the first term. Because as you know, the sum of a geometric series to infinity is defined as the first term divided by 1 minus the common ratio. Now what's the common ratio? That's just the ratio between two consecutive terms, and it's constant throughout the series. That's the definition of a geometric series. But good news is that we know the first term, here only a, so that's 8, but we still don't know the common ratio. But a6 divided by a5, by definition, is the common ratio r. And that's some positive number divided by 2, which is also a positive number. So we know that r must be positive. Then a1 obviously equals a1, and a2 will be a1 times r. And so on, we'll always multiply by r to the next step, until we get to a5, which is a1 times the common ratio to the 4th power. So let's try and get the most out of this new piece of information. So it must be that a5 divided by a1 is r to the 4th power, and that equals 2 divided by 8 is 1/4. Now we need to be careful because r equals the 4th root of 1/4, but always when taking a root we need to be careful about the signs, and here in fact, we could equally have a plus and a minus sign. Even minus this number to the 4th power is 1/4. But luckily, we know from before that r has to be positive. So only positive is our solution for r. And this is now the square root of 1/4. So the square root of 1/2, and that's 1 over root 2. And that's great news because we know the first term, a, here, 8, and the common ratio, 1 over root 2. So we can only substitute into this formula and we should get our sum to infinity. So this is it, and we'll need some more rearrangements to make it look a bit neater. We don't want any roots in the denominator, so let's just multiply top and bottom by 1 plus 1 over root 2. So that's 8 divided by 1/2, 1 plus 1 over root 2. And because dividing by 1/2 is the same as multiplying the expression by 2, so that's as if we multiplied this by 2 plus 2 divided by root 2 is just root 2. And that's our final answer to the sum of this series to infinity. And in the exam, it was option C.